GenServer callbacks help abstract message receiving functionality of Elixir processes. These abstractions provide a way to receive messages from other GenServer processes as well as custom messages or messages coming from the system. This presentation is going to go over the syntax and structure of some callback methods, provide a few use cases and examples, and talk about how GenServer could help us take advantage of Elixir's ability to execute code concurrently. If you are new to GenServer concepts like initialization and callbacks, please check out a previous video in this series that goes over GenServer basics and provides a few introductory examples. GenServer has three callbacks that help abstract process communication: handle call, handle cast, and handle info. Their syntax is very similar, with a few important differences. When they are called, they all get access to the current state of the GenServer process, and they all get to reset the state in their response. Handle call also receives a from argument when it gets called, and it replies with a 3-element tuple, with the second element being the return value. Handle cast and handle info respond with a 2-element tuple, no reply, and the new state of the process. Please note that because they have no return value, the first element of the response tuple is no reply, unlike the reply in handle call. Let's start a GenServer process and go over how these methods are used. Handle call gets triggered by GenServer call method. Typically, a method that runs GenServer call will expect some kind of a return value. In this case, what you're going to see is this output, with the response variable being an empty list we assigned during initialization. Handle call is synchronous, or blocking, meaning it will not execute any code below GenServer call until it receives a reply. This method can be used for both setting and retrieving state information in a specific GenServer process. Handle cast gets triggered by GenServer cast. This is a method you want to use when you don't need to receive an immediate reply, and want to take advantage of Elixir's ability to execute code concurrently. Handle cast has a slightly different syntax from handle call. Mainly, there are less elements to worry about. It does not have a from argument, and it does not have a reply. You still have to respond with a tuple, but it will have 2 elements instead of 3. Handle cast is asynchronous, or non-blocking, meaning it will not wait for the method to finish before executing the code below it. Inside it, you'll have access to GenServer process state, and you can set it, but don't expect this method to return any data. When you run it, the only thing GenServer cast returns is OK. Handle info has syntax that is pretty much identical to handle cast. It's also asynchronous. The difference is there isn't an explicit GenServer trigger method associated with it. There is no genserver.info. Handle info is used for receiving messages from everyone except the GenServer. It can receive messages from any Elixir process. To test it, you could use Elixir process module. Process send method takes 3 arguments: the process ID, the message tuple, and options. Internally, handle info works exactly the same way handle cast does. You have access to the process state, and you can reset it. And just like handle cast, it always responds with OK. Handle info could be used for a number of different things. It could be used for catching shutdown messages for GenServer processes, and you can use it for logging or notifications. But as you saw, any process could send handle info a message. When thinking about concurrency and synchronous versus asynchronous execution, I like to use a package delivery analogy. Let's say there's a delivery company called Elixir. They provide 2 types of deliveries, ones you have to sign for, and ones the delivery person can just leave by the door. The deliveries that have to get signatures are synchronous. The delivery person has to wait for you to sign for the package before making any other deliveries. They'd have to wait for the recipient to respond for every package, no matter how fast they can get it there. On the other hand, packages that leave by the door are asynchronous. They leave them, maybe ring the doorbell, and leave. They don't care when you're going to pick it up, and at the same time, they did their job. Asynchronous package delivery is much more efficient. For synchronous delivery, you're required to wait for a response for each package, and typically, you have no control over the response time. For asynchronous delivery, you are not blocked by each package and can therefore function much more efficiently. You don't have control over when the package is going to be received, and in terms of a delivery business, you don't really care unless something goes wrong. Let's continue with this analogy and see it in action. In this example, we're going to have two modules, a GenServer package receiver and some regular module that's going to be calling it. It isn't necessary to have another module for the caller, but it helps to keep their concerns separate. Package delivery module is going to define a list, start a package receiver GenServer process, enumerate over each package, and call leave at the door method of the package receiver. Leave at the door method is going to call GenServer cast method. Even though inside of this method each package is going to take 1 second to be received, this will not block the iteration. In fact, you're going to see all done with deliveries before we see the first package being received. Let's see it in action. When we call this method, we're going to see all done with deliveries printed way before we're going to see I received a package. After a second passes, you're going to see I received a package printed 1 second at a time. As you can see, we got all done with deliveries almost right away, and each delivered package took a second to be received. So this is an example of asynchronous Elixir code in action. While this was a good start, we still took a total of 4 seconds to receive all the packages. It's important to understand that while we are calling a GenServer process asynchronously, it still has to process one message at a time. Each Elixir process has a mailbox that receives all the messages addressed to them. What we've done here is send all 4 messages to this one process, but this process still had to deal with them one at a time, each one taking a second. One way to address this is to start one process for every message, in which case it will only take about a second to process all 4. Now, this is far from best practices, but one way we can demonstrate this here is to start a GenServer process inside the enumerator. This will start a process for every package. When you run this method, you're going to see all done with deliveries right away, and all the package received messages a second later that will all be printed at the same time. As I mentioned before, this is far from best practices. We don't want to start an unknown number of GenServer processes with no way of knowing what's going on with them. How do we know if leave by the door method succeeded, and what should happen if it doesn't? Elixir has a specific way of keeping an eye on GenServer processes with a module called a supervisor. Supervisors can handle stopping, restarting, and generally monitoring GenServer processes in a robust and flexible way. But more on that at another time. The goal for this video was to cover the GenServer essentials for you to continue learning and perhaps starting to test out GenServer in your own projects. I hope this provided you with a good starting point. Please keep revisiting the GenServer documentation and continue to expand your Elixir and GenServer knowledge. Thank you for watching.